Alrighty, Algebra 1 students, welcome to lesson 1.5 or part 5 in your unit 1. And this is actually then part 2 of the part 5. So you should have already had watched the part 1 as we had done that a couple days ago in class and discussing your square roots of different operations. For part 2 then here, what we're going to do is I can classify numbers within the real number system. So we're going to be talking about real numbers and how we classify them, or what we would consider to call them in their definition. So a lot of this is going to be reviewing what are real numbers and how to remember what is what, and so it'll end up being a lot of notes. So I would have your notebook out so you can follow along and write down what each type of number is. To be honest with you, it's something I don't even always remember, and so writing it down, the more you write something down, as well as the more I talk about something or you talk about it, the more you're going to remember it. So we only then have 2 examples on classifying these real numbers, but a lot of it is just going through and talking about what each number kind of represents. So here is one description, and this one is for the most part some word definitions, and then we have another part with some word definitions and a table here as well that we'll continue looking at. So what the biggest thing to do is to understand if we've got so we have real numbers. We haven't gotten to the part of imaginary numbers in math yet. So all your numbers are considered to be real numbers. And then there's other classifications under the real numbers. So you've got things like natural numbers. So those are your counting numbers. When you count 1, 2, 3, 4, 5. So that's basically includes everything that's positive as far as you want to go up. But it does not include 0. Because I usually don't. I mean, when you start counting, do you ever start counting with 0, 0? Sometimes you do, but most people start with 1. Your whole numbers then are your natural numbers, so that would include your 0. So I could write myself a little note like, okay, 0, or it could be like no 0 for your natural numbers, and then whole numbers are 0. Integers, as we've continued to talk about adding, subtracting, multiplying, dividing integers, are the whole numbers and their opposites. So I can have negative values, -3 and its opposite, which is a +3, -2 and its opposite, which is a 2, 0 still counts in my integers. So those are everything negative as well as positive. So those are some of the big parts here first. And then we get into then creating another distinction between rational. So here are our rational numbers, and then we will talk on the next page about irrational numbers. So rational numbers are numbers that can be expressed in the form a out of b, where a and b are both integers, but b cannot be 0. So what it means is that if I can write that number in a fraction form, it's considered to be rational. So if I wanted to think about 2, I can write 2 in a fraction form because 2 divided by what would give me 2? 2 divided by 1. So 2 would be considered rational, as well as then its negative form, -2, because I can do -2 out of 1. So it doesn't actually have to be written in that normal fraction form for it to actually be something you can express in a fraction, because remember, you can always take whole numbers, integers, natural numbers, change them into fractions. The only thing and the only trouble is if you get into dividing by 0, like 5 divided by 0. You can't do that. That's undefined, so that's why they say where it cannot equal 0. When expressed as a decimal, so you can also, remember, you can also take things as a decimal. So for instance, if I had 0.25, that's the same as 1/4. So that would be considered a rational number. It can be written in a fraction form if I'd like to. So it says when expressing a decimal, a rational number is either a terminating decimal or a repeating decimal. So a terminating decimal is a lot like the one I just did right here. It's a decimal that has a very clear end. It's going to stop. It's not going to continue on. It's just 0.25. That's all it is. A repeating decimal then obviously repeats, has a block of 1 or 2 digits after the decimal and repeats. So it might be like something like this, 1, 2, 1, 2, 1, 2, 1, 2. Or the most common one is if you had 1/3 and you make it, you know, a decimal. It's just 0.3333333333 going on. And so a lot of times you'll just write it as the decimal place and 3 and a line above it. So that's another way you can also represent things that are repeating decimals, is by adding that line above that value, or the parts that are being repeated. So in the case that this one, 0.1212, the 1 and the 2 are being repeated. So if I wanted to write this out, I'd write 1, 2 with the line above, because those are both repeating. Okay. Again, take a minute to pause. I know this was a lot of information. I would pause the video and just take a deep breath. Just let it sit in. Take a minute. Okay. Write down what you feel like you need. Ask questions if you're still confused. I'm going to tell you, I don't even remember some of these, but it'll be important to know as much as you can as we continue on and talking about these different kind of numbers. All right, so then your irrational. So we talked about rational, but we haven't talked about irrational. So rational numbers are all real numbers that are not rational. So obviously, if they're not rational, they're irrational. So it means that you cannot express it in a form of a out of b. So you can't ever change it into a fraction form. Again, where a and b are integers and b does not equal 0. They are neither terminating decimals nor repeating decimals. So for example, in this case, they use this decimal. What happens is you get the 1 continuing going, but notice that every time you continue to the 1, there's another 0. So there's 1 0 here, 2 zeros here, 3 zeros here, 4 before you get to a 1, probably 5 till you get to a 1. And so it's not a clear pattern, or it's a pattern, but it's not a pattern that continues to be the same every time. It's not like, okay, 1, 2, 3, 1, 2, 3. It's changing and it's evolving as it goes through, and so this is considered a rational number, or irrational number. It says this decimal neither terminates nor repeats, so it is irrational. If a whole number is not a perfect square, then its square root is irrational. So in the other part of this lesson, we talked about square roots. And I know, for example, that last one, we were talking about the square root of 19. Square root of 19 is not a perfect square. And so in that case, your square root is irrational. Or if you were to solve this, this is also an example of an irrational number. And they also give you the example of the square root of 2. So here's this really nifty chart on how we can do this. And I know I have another cool poster. I really want to be able to find this poster. I will probably take a picture of this poster and upload it with this material too, if you would like to have that. It is somewhere in this classroom and I will find it to show you. So basically what they did is they divide these into different sections so that you can see what fits together, what doesn't fit together. So all real numbers, remember we're only talking about real numbers so far, all real numbers can be classified either in a rational number or an irrational number. So as you can see, the irrational number side only has irrational stuff in there, okay? Things that aren't perfect squares, as you can see, pi is then irrational because it's not a decimal that we can emulate. It just continues going to random, decimal places. And so then from here, so everything in this box is a rational number. The further we move in, okay, so then I've got integers in this part. So everything in this big bubble here, including this whole numbers and these natural numbers, are my integers. Then in the next part, everything is my whole number and then my natural numbers. So here's also some examples too. They use kind of some symbols over here. I don't use them very often, but if you want to explain, rational would be R, irrational, I guess, real numbers is R, rationals are Q, integers Z, whole numbers W, natural numbers N. Don't tell me, I don't know why they call the integers Z, or rational numbers Q, but there is that as well. Alrighty, so here are the examples then. And what we need to do is take a look at these numbers and decide and classify them. So write all classifications that apply to each number. So your first part is going to be, is it rational or is it irrational? So starting off, remember rational means you can write it in a fraction form. And this would be my fraction form. It should really look like this. It's just not easy to write on my computer. So yes, this is a rational number, so I would say rational. Okay. From there then I would think, okay, is it an integer? Let's think. An integer is going to be any whole number. So since it's a fraction and you could simplify it to, as 8/9. It's not even a whole value of 1 yet. This is all that's going to be. It's just rational. I can't put it as a whole number, I can't put it as an integer, and I can't put it as a natural number. But let's look at 18, okay? 18, thinking again, I want to think, is it rational or irrational? Basically, if it's irrational, it's going to have a weird decimal. So, in this case, it doesn't have any weird decimals, and it doesn't have some weird decimal that doesn't make any sense, so it is considered rational. Once we get into rational, we want to think then, if I look at this chart, all right, is it an integer? Remember that integers can be both positive or negative. So yeah, it's an integer. All right, how about then, is it a whole number? Remember whole numbers are 0 and up. Yeah, it's a positive number, so it'd be a whole number. I'm going to use the pound symbol or the hashtag because that also means number. And then your last one, let's see. Is it then a natural number? It is because it's above 0. We're just going to abbreviate NN, natural number. So 18 would be rational, it would be an integer, it'd be a whole number, and it would be a natural number. A is just rational because it is a fraction. Remember, integers have to be an actual whole value, but they can be positive or negative. Whole numbers then are going to be 0 and above, and natural numbers are 1 and above or higher. And then see here, we have a square root of 20, and square root of 20 is not a perfect square. And so if you go back and look, if a whole number is not a perfect square, then its square root is irrational. So my answer for this one, and all it is irrational. All right, so let's take a look at these ones. This one's more so pause and practice, so I want you to take a minute to pause this video and write these down, and I want you to see if you can solve these before I solve them. So feel free, you can always go back in this video if you need to see kind of that chart again to help you decide, but write all the classifications that you can find. So your first question, is it rational or irrational? Start there. If it's irrational, that's all it's going to be. If it's rational, then start thinking, is it an integer? Is it a whole number? Is it a natural number? All right, so go ahead, pause this video. Once you get back, we will discuss the solutions. Yes, I do mean pause the video and do the work. You can't just skip ahead and wait for me to continue on. Coming on back, here are my classifications for each one. So for A, it is just rational because it is a fraction form that cannot be simplified, cannot make it into a whole value, so it can't be considered an integer. So I have that. But B is going down, if you can see. B is -12. B is irrational, because I could always write it as -12 out of 1. It's an integer, it's a whole number, and it's a natural number. C then is the square root of 10. That's not a perfect square, so it's just automatically irrational. And D is a perfect square. It is the square root of 100, which equals 10. 10 then is a rational number. It's an integer. It's a whole number. Oh, I messed this one up. And a natural number. Oh, these should not be whole and natural. Because it's negative, it should only be rational and integer. Whole numbers are 0 and up, and natural numbers are 1 and up.